Hello, ChemCavs. We are here today to learn about gas stoichiometry. So in order to do this, this is a brand new equation that you're going to need to know. PV equals nRT. I happen to have been taught this, and it's stuck with me ever since as the pervert equation. This is kind of a STAMism now, since my high school chemistry teacher is retired. I don't think it's being mentioned as such in university, but that's what it is. Really, it would read it as perv-nert, but there's no such thing as perv-nert, so I just remember it as the pervert equation. Now, technically what this is called is the ideal gas law, okay? Now, when we go through this, P stands for pressure. Pressure has to be in kilopascals, okay? Now, if you don't understand what pressure is, I want you to Google or go on YouTube and search for an explanation of gas pressure so you understand what it is. It's very, very important that you're able to understand it. I will give you a brief explanation now. If you have particles and they're pushing on the walls of the container, that would be gas pressure. Now, those particles, okay, it doesn't matter the type of gas particles. What matters is the amount of gas particles that hits the walls of the container. All right, so it doesn't matter, as an example, if you fill your car tire with air, which would be a combination of nitrogen, oxygen, carbon dioxide, and some other trace gases. You could fill your tire with chlorine gas. You could fill it with nitrogen gas. You could fill it with carbon dioxide. You could fill it with helium. And if you filled it to the proper amount, your tire would be properly inflated. It depends on the amount of gas particles, not the type. V is volume. Now, volume has to be in liters, okay? So again, make sure that you're able to convert between milliliters and liters. Little n, this is the little n that we've been dealing with now, it seems like, for a couple of months. It's the number of moles. R is a constant. So this number you would have to memorize. It's 8.314. That's a number you just have to sit there and memorize. And then temperature happens to be in Kelvin. Now, this is a new temperature. You're probably used to, well, I know you're used to degrees Celsius, and you're probably used to Fahrenheit. This is a new one. You are also going to have to know how to convert back and forth. I will generally never give you temperature in Kelvin. I will always give it to you in degrees Celsius, and you have to be able to convert it. So generally, you take your temperature that's in degrees Celsius, you add 273 to it, and then you will have your temperature in Kelvin. Okay, so that's what we're going to be dealing with. So what I want to do is I want to go through a Stoich problem as an example with you, and then we've been doing Stoich so often that this really shouldn't be too difficult for you. So I am going to have you look at the first question here, okay? So it reads, what volume of oxygen is required for the complete combustion of 152 grams of glucose? And then I also want to know what is the volume of carbon dioxide is produced if the system is at STP. We'll get to STP in a minute, and then obviously I've given you the formula. So in any single Stoich question that we ever do, we have to write out the formula. So the formula is C6H12O6, which is glucose. We're going to react it with oxygen gas. So this is a combustion reaction, and we are always producing carbon dioxide, which again is a gas, and we would produce water. Now, because it's combustion, water would be in the gas stage. Think about it. If you burned something and you produced water and it was a liquid, it would just put out the fire. Okay? So again, as with all these Stoich questions, feel free to pause the video, balance it, write down your givens, and then just keep playing the video when you get stuck, or to have me catch up to wherever you are. So the first thing we have to do is we have to balance this. And in order to balance this, I have 6 carbons there. I want 6 there. I have 12 hydrogens. I want 12 here. So 6 times 2 is 12. I have, let's see, 12 and 6, that's 18. 6, so if I make this a 6, I have 18 oxygens on that side, and now it's balanced. All right. Second step is we want to set up our columns, like always. And now we want to put down all of our givens. All right, so I want to know what volume of oxygen gas I need is required for the complete combustion of 152 grams of glucose. So that is mass, 152 grams. And remember, molar mass and mass go hand in hand. I'm not going to do that yet. I also want to know the volume of carbon dioxide that is going to be produced. It's a gas. And I make no mention of water, so I'm not going to do any calculation there. Now, the other thing you need to know is it said that this system was at something called STP. STP equals standard temp and pressure. Okay? Now, this is something that I would normally tell my grade 11 students that you have to memorize this. Standard temperature and pressure. Standard pressure is 101.3 kilopascals. All right, and standard temperature is 273 Kelvin. So that will make life a lot easier if you remember that. So the system is at STP, so that means my temperature is going to be 273 Kelvin. Pressure is going to be 101.3 kilopascals. Now, temperature and pressure only affects gases. So I am not worried about temperature and pressure for glucose because it's a solid. All right, it only affects gases, so you are only using the pervert equation, and you're only putting down temperature and pressure and those kind of things for a gas. If it's not a gas, you are using one of the other equations that we've already worked with. So temperature over here is also going to be 273 Kelvin, and pressure is going to be 101.3 kilopascals. All right. So at this stage, I've written down all my givens. So now I'm going to find the molar mass of glucose. So it's 6 times 12 plus 12 times 1 plus 6 times 16. And when I do that, I am going to get 180.0 grams per mole. Okay, so now I've gotten all my givens. So the next step is I generally would, unless it's given to you, you're generally going to have to find the number of moles of something. And I need to find the number of moles of glucose. And I can do that because of mass divided by molar mass, and I'm given both, sort of, even though you technically found the molar mass. As soon as you're given the formula, you can do that. So it's 152 divided by 180. 180, and I'm going to get 0.844 moles. All right. Now, this is not a limiting reactant question because I did not give you enough information here where you could find the number of moles. Okay. So I know that I am going to start at 152 grams, and by the end of the reaction, I'm not going to have anything left. I know that I'm going to find out exactly how much I need. I'm not going to have any of this left. That's the whole point. You're calculating exactly how much you need to use here. So what I want to do, transfer to column, is I want to do a mole to mole ratio. Line equals line. The original ratio is 1 to 6. I don't have 1 mole. I have 0.844 moles. And I want to find what N is. So I'm just going to go times 6. And there's a lot of moles here. And that's what we have. Okay. Now, I want to find volume. It's a gas. Now, be careful. You're not using N equals C times V here. That's only used for solutions. This is not a solution. It's a gas. So I have to use pervert. PV equals nRT. So my pressure is 101.3 kilopascals. Volume 5.07. R is 8.314, and my temperature is 273. So I'm going to multiply these three together and then divide by 101.3. So 5.07 times 8.314 times 273 divided by 101.3. And when I do that, I get a massive amount of oxygen gas I'm going to need. I'm going to need 113.52 liters. So that's how much I would have to start with. And like I said, at the end of the reaction, I'm going to end up with nothing. Okay. I also know that carbon dioxide, I'm going to start with nothing and I'm going to proceed forward. We don't care about water, But I do know I'm not going to have any of it to start with, and I'm going to eventually make a certain amount, which I didn't have to calculate. All right. Have to do a mole to mole, again, between glucose and carbon dioxide. Now, if you got your thinking cap on, you'll already go, hey, I just did that here. So it's the exact same calculation. If you want to save time, I'm not actually doing the calculation. I'm just copying it over. I have faith in my calculation over here was correct. I'm running out of room, so I'm just going to move it down here. Now I have to use pervert again, find the volume. Pressure is 101.3. Volume is what I want to find, 5.07, 8.314, and 273 is my temperature. And when I do this, you may have already been noticing this, I'm going to get exactly the same amount, okay? That makes a little bit of sense. Think about it. You're using, for every 6 oxygens you're using, you're making 6 carbon dioxides. So if you're going to use 113.52 liters, you're going to make the same amount. It's a 1-to-1 ratio or a 6-to-6 ratio, all right? So I'm going to start with nothing, and by the end, I'm going to make 113.52 liters. And that's kind of how you do pervert in a gas stoich. You're not always going to ask for volume. I could ask you for pressure. I could ask you for temperature as well, okay? So any of those I could ask for. I will not ask you for R. Remember, R is a constant, so it's always 8.314, and that doesn't ever change. All right? Good luck. I just showed you how to do question 1. Now you guys just have to work through questions 2 to 7. Take care.